Hello everyone, welcome to the new video. Today we are going to begin with the next chapter, that is electrolysis. Electrolysis is one of the very important chapters, so let us begin the video. Electrolysis. What does this term mean? Electro, that means something energy, that is related to electrical energy, that is electricity, right? And lysis, that means to separate. So separation caused by electricity is electrolysis. Before we go to electrolysis, we need to know about certain terms. 4 different terms I am writing. First term is a conductor, not the conductor which we have learned in physics. Partially it is, okay. Conductor. Conductor is a substance that can conduct electricity in solid state, in molten state, without any chemical change. What is the keyword? Without any chemical change. Clear? If you forget it, it can be even an electrolyte. Clear? So conductor, and number 2 I am writing is electrolyte. Number 2 I am writing is electrolyte. So what is the difference between these two? Very important question. See, conductor is a substance that will conduct electricity in solid state, in molten state, without undergoing in any chemical change. Difference we are coming to later. Okay, definition. Electrolyte, substance that will conduct electricity in liquid state, that is in molten state, actually not liquid state, molten state or fused state or aqueous state, undergoing a chemical change. Clear? Okay. Conductor is a property of a metal, and electrolyte is a compound, ionic compound. Okay, it cannot be a metal. We are coming to the difference a little bit later. First let us discuss this. Okay, then comes 2 more terms, insulator or non-conductor, same thing, and number 4 is non-electrolyte. So this you can understand. Insulators, not conducting electricity in solid state, liquid state, gaseous state, whatever state it be, not conducting electricity. Khatam. Non-electrolyte, not conducting electricity in liquid state, molten state, aqueous state, fused state, not conducting. Non-electrolyte. Solid state it will not conduct only. Okay, clear? So these are what you need to remember. Conductor example you can give, non-conductor example you can give, that is insulator. Electrolyte example you can give. What is electrolyte example? Electrolyte example is NaOH. Non-electrolyte example is sugar solution. What solution? Sugar solution. This I should not write, but I am writing one, Cu, and these are non-metals. Okay, non-metals. Exception, write the exception in comments. Okay, insulator, non-conductor, non-metals. Exception is there, write the exception in comments. Okay. Okay, understood this part? Now let us differentiate between this person and this person. Where lies the difference? As I have already told you, conductor is going to be the property of metals. So it is the property of metals. But electrolyte's property is electrolytic conductivity. So differentiation is going on between metallic conductivity and electrolytic conductivity. Question might come is differentiate between Cu and CuSO4. Differentiate between Cu and CuSO4 or Mg and MgSO4 can come as a difference. What will you write? You have to write the difference between metallic conductivity and electrolytic conductivity. Metallic conductivity, what is happening? In metallic conductivity, what happens? Physics you have learned. If this is the cross section of a metal, let us say this is the cross section of a metal. So in this electron moving, proton is also there, collision is happening, resistance is happening, so many things are happening. I have this bothered about that. But current is flowing through that. So current is flowing due to which particle? Electron particle. In direction, opposite direction. Current will flow, suppose current is flowing in this direction. Clear? But electron they will flow in this direction. If current is flowing in this direction, this is current, then electron will flow in this direction. So current is being due to which particle? Electron. Current is due to which particle? Electron. Current is due to which particle? Electron. So in case of metallic conductivity, current is due to electron. But if we take electrolyte, then current is due to the two stream of ions. One is the cation, it is moving towards the negative potential, not the negative potential, towards the negative electrode, and one is the anion moving towards the positive electrode, right? So this is form, the electricity is conducted by two stream of ions, while in metallic conductor it is one single stream, that is electrons. First difference over. Second difference, metallic conductivity is the property of metals, while electrolytic conductivity is the property of ionic compounds. Clear? Next, metallic conductivity is done both in solid state or molten state or liquid state or fused state. So you cannot fuse copper. Okay, but electrolytic conductivity is only possible in molten state, fused state or aqueous state. Right? Right? Okay. Next difference. In case of electrolytic conductivity, chemical change takes place, new product is formed at the electrodes. But is it so in case of metallic conductivity? No. In case of metallic conductivity, no chemical change undergoes, only physical change, no new product formation. Last point of difference, the current carrying particles in case of metallic conductivity is very small as compared to electrolytic conductivity. As you can understand, electrons and ions, size of ions definitely are bigger than electron, obviously. Okay, so in case of electrolytic conductivity, the ions are conducting, so size is more as comparatively to that of the metallic conductivity, and in case of metallic conductivity, the size is less than the electrolytic conductivity. Understood? Now let us learn the definition of what the chapter name says. Electrolysis. What exactly is electrolysis? Things that you need to remember while writing the definition of electrolysis, please. Electrolysis. See, electrolysis is the decomposition. What is the first keyword? Decomposition. Decomposition. It cannot be a synthesis. It has to be a decomposition. Decomposition of a chemical compound. Chemical compound in aqueous state or molten state or fused state. Aqueous, molten, fused. Three things needs to be mentioned. Either of three you can mention, but either of three you mention. Fine. Done. Accompanied by a chemical change. That is not the keyword. Chemical change by using direct electric current. By using direct electric current. Now what is direct and alternating current? You might have read in physics. Okay. So it is direct electric current. What are the keywords? Decomposition of a chemical compound in aqueous state, molten state, fused state, accompanied by a chemical change with the help of direct electric current. With the help of or by using direct electric current. Clear? So these three things must be there in an answer. I missed out any one thing, problem might arise. Clear? Must write these three things in an answer. Decomposition, aqueous, molten, fused, direct electric current. This is a proper definition for electrolysis. Okay, electrolyte definition already told before. Example of electrolyte also I have told. NaOH is there, H2SO4 is there, and every acid is electrolyte. Clear? Okay. Now electrolyte is of two types. One is strong electrolyte, one is weak electrolyte, one is non-electrolyte. Basically we say the type of electrolyte is strong and weak, that is electrolytes type. So strong and weak electrolyte. Strong means very much electricity is conducting, weak means comparatively less electricity is taking. Clear? And non-electrolyte is not conducting electricity only. Clear? Strong electrolyte example NaOH, KOH. Weak electrolyte is CaOH whole 2. Okay, NH4OH is also weak electrolyte. Clear? Okay. Now differentiation between strong and weak, I have already told one differentiation. large amount of current, less amount of current. Poor, good conductor, strong, weak conductor, poor. Clear? Bulb will grow very strongly, bulb will go dimly. Clear? These are the differences that you need to mention. Others are also there, like they are complete dissociate, they partially dissociate, they have fully ions, they have ions molecules. Clear? Bulb part is, do not write that. That is very obsolete type of difference. Okay. Write the first four. That are very important differences. At least first difference has to be mentioned. It is the most important one. And that ion molecule is also very important. Complete dissociation is also very important. Okay. That is the difference. Done. Now let us move on to the next part, that is voltameter. Okay. Many of you will end up writing voltmeter in the paper. Many of you will end up writing voltmeter. Voltmeter. This. If you write this, 0. What is voltmeter? Something that measures the potential difference. It is in physics. I am not talking about voltmeter. I am talking about another thing. That is not voltmeter. That is called voltameter. That is voltameter. Voltameter. Okay, not voltmeter. Voltmeter is different. Acha. This has got another name. That is called electrolytic cell. That is called electrolytic cell. That is called electrolytic cell. What happens in electrolytic cell? It's basically, if we take like this, okay, then there are two electrodes like this. There are two electrodes like this. So this was just for support. Okay, I am drawing freehand, so do not judge my drawing, please. Okay, there will be some electrolytes, whatever electrolyte you want to give. Then there will be a connection with a battery over here. I will do a connection like this. Some connection will be there with a battery. Okay, this is going to be the connection. So this is going to be an electrolytic cell setup. Two electrodes are there, electrolyte is there, battery circuit is completed. Clear? Circuit is completed. Okay, negative terminal, positive terminal. Okay, this is a simple electrolytic cell, or called a voltameter. So what is that? This vessel that we have taken must be a non-conducting vessel. Any common reason you can give. Why? Whenever you want to touch it, you will get electric current. That we do not want. So it is a non-conducting vessel. Clear? Non-conducting vessel with two electrodes. You can see the two electrodes. Two electrodes are dipped inside it. Two electrodes are immersed in a solution of electrolytes to bring about a chemical reaction is said to be an electrolytic cell. Clear? Electrolytic cell will convert which energy to which energy? Common sense. Battery is there, but not electrical to chemical. Electrical to chemical. It will use up the electrical energy of the battery and it will convert it into positive chemical energy. Clear? So electrical energy to chemical energy is voltameter. That is electrolytic cell. Okay. Next is the opposite of this. Not the opposite, but kind of. So it's the electrochemical cell. It's the electrochemical cell. Electrochemical cell is basically converting your chemical to electrical. Previously was electrical to chemical. This is chemical to electrical. Clear? Electrochemical cell has got simple voltaic cell, Daniel cell. Okay, Daniel cell actually. Then class 12. Okay, electrodes. Now we are talking about this electrode. Just now we saw that in this solution we had, sorry, not a solution. Inside this tube, inside this container, we have immersed two electrodes. What are these electrodes? So you see, these electrodes are something that is letting the current flow in and out. Letting the current flow in and out. Without the electrode, will the current enter? Cannot enter. So electrodes are letting the current to go and out. So they are the, what to say, carriers of electricity. They are letting in the electricity to go and out. So how will you define it? You will define it as two metal plates. Can be even a wire. So two metal plates, or wires, or gas carbon rods, or graphite rods. We know that electrodes can be of graphite. So it can be graphite rods, it can be gas carbon rod, it can be metal rod, it can be wire. What is its function? To let current in and out. Done. Electrode definition. Okay. Now the problem comes. which one is the anode and which one is the cathode. See, anion, you remember, everyone knows anion, everyone knows cation. Acha. Anion A has, so anion will be anode. Think properly. Cation is C, so it will be cathode. Clear? So this person will go to this person will go to this. Right? Now when can a person go to this? Think properly. Anion is negative, cation is positive. If you remember this thing all, it will be okay. Check properly. Anion A, it is anode. A cannot be cathode. Cation C, cathode C. C will go to C. Okay. Now think. Anion has got a negative charge. Can a negative charge go towards a negative charge? It can go, but you need to do some work. That is a different thing. Okay, but will a positive charge, negative charge tend to go to a negative charge? No. It will try to get repelled away. But why does it go? Why? Because it is a positive charge. I said already that anion will go to anode. When can it go to anode? When it is opposite charge. So anion is negative charge. So anode is positive charge. Clear? This is positive, so this has to be negative. So how to remember? Cation goes to cathode. Cation is positive charge. Positive cannot go to positive, so it has to go to negative. Anion is negative charge. Negative cannot go to negative, it has to go to a positive charge. So negative goes to positive charge. So anion goes to anode. Anode is positive charge. Now how will you identify in the diagram? You have to see this battery diagram. Battery diagram will be like this. This will be a circuit. Bigger dundee you see, plus. Smaller dundee, minus. Clear? So positive terminal connected means anode. This means cathode. Clear? This is not ammeter, please. Clear? So this is anode, this is cathode. This is the kind of thing that you need to check, because diagram based question will be coming in the exam, and in that case it might not be told which one is anode and which one is cathode, and it must be told that identify A and B. How will you identify it? To check this part, this portion. Bigger dundee you see, it is the plus. Smaller dundee, it is the minus. Okay? Understood? Cathode and anode. This is the complete concept of cathode anode. You can remember this. Very well, very good. Okay. Now another thing you have to remember. So now see, suppose sodium, positive charge, so going to cathode. Right? Okay. Sodium will go to cathode. So metal, cathode. Suppose it is Cl minus, anode. So non-metal, anode. So metals will go to cathode, negative elements, that is the non-metals, will go to anode. So you will be saying cathode as the electropositive electrode, electronegative electrode. Clear? Why I am coming to this a little bit later when I tell you about oxidation reduction, then we will be discussing about this oxidation reduction. Okay, I am just telling that sodium will go to cathode, chlorine will go to anode. Okay? Okay. Now the next thing is difference between anode cathode. I am not saying the difference between anode cathode, very easy thing. Next is ions. Ion definition you know, group of atoms or group of atoms or one atom or group of atom which carry a positive negative charge is called ions. Clear? Next is anion cation difference, that is also nothing to be said, you can read it on your own. Now we are coming to the main thing, that is a very important thing. Check. Sodium ion plus electron will give you sodium metal, right or wrong? Acha. Positive charge over here, positive charge over here. You have to be. It cannot be like this. If you end up writing in the exam like this, then I have got nothing to say. This positive will not be here negative. This is positive, then this has just to be positive. Remember it this way. Remember it in this way. Mg to positive. What charge? Positive. What will be remaining? Positive only. Plus 2 electron forms Mg. Clear? So oxidation in its electronic concept is said to be the loss of electrons. Clear? Oxidation is said to be loss of electrons. Clear? Acha. These are all reductions. This is not possible only. This is reduction, this is reduction. Why? Gain of electrons. Gain of electron is reduction. Loss of electron is oxidation. Check. Cl minus charge is there, so minus of electron forms Cl. Clear? What happened? Minus happened, so oxidation happened. Loss of electron, oxidation. Gain of electron, reduction. That is electronic concept. Check properly this side. This positive sign, here also positive sign will sit. positive, here also positive. Cannot be a negative sign sitting there. Clear? You see this sign, this will also be the same sign. Clear? Now applying this to electrolytes, electrolysis. Acha. Tell me, Na plus ion will go to which electrode? I have said before also, plus will go to minus electrode, and which is a cation. So cation will go to cathode. So it will go to cathode. So what type of reaction is happening to form Na? Reduction, oxidation, reduction. So at cathode, reduction occurs. Clear? At cathode, reduction has to occur. At cathode, reduction has to occur. Okay? Now see here. This is what? Negative moves to anode. Anode is what? Positively charged. This is losing electrons. What is it happening? Oxidation. So what can you conclude about anode? Anode is the oxidizing electrode, or oxidation occurs in the anode, reduction occurs in the cathode. So always when it is asked reactions at cathode and anode, you have to write the proper this at least. Maybe you are forgetting something, that is okay, can forget, but this should not be wrong. Okay, plus, minus, cannot be minus plus. Okay, so cathode is the reducing electrode, oxidizing electrode is the anode. Remember it forever. Okay. Oxidation definition is given in your book. Lot of ways definition is given. Read the electronic concept. Okay. Loss of electron or removal of hydrogen or addition of oxygen. These are all oxidations. Okay. Reduction also I have told. The opposite of what is oxidation. Okay. Now the another question that comes often. Example of reducing agent and oxidizing. Hopefully everyone can write. Everyone knows oxidizing and reducing agent. But the thing that is asked in the question is, name a reducing agent as well as an oxidizing agent. Name a reducing agent as well as an oxidizing agent. And that is where people go wrong. Okay. See, H2O2, that is hydrogen peroxide. This is both oxidizing and reducing agent. And another one is there, that is SO2, sulfur dioxide. Now if it is asked liquid, then this one. If it is asked gaseous, this one. This is existing in liquid state and this is existing in gaseous state. So if liquid is asked, we will write H2O2. If gaseous is asked, we will write SO2. This is the thing that is generally asked in the question. Rest you can write. You already know it. Okay? Is it understood? Okay. Next we will move on to Vante's theory of electrolytic dissociation. Vante's theory of electrolytic dissociation. Actually it is Arrhenius theory of electrolytic dissociation. So it's Arrhenius theory of electrolytic dissociation. So I am writing Arrhenius theory. Arrhenius theory states that electrolytes upon dissolving in water, when it dissolves in water, it will dissociate to form plus V ion, that is positive ions, and negative ions, that is cation and anion. Clear? And electric current will flow thereafter inside it. Next what he said was that all ions carry electric charge, and all the ions, be it the cation or be it the anion, they all are responsible for the flow of electric current. Clear? Next, they have told, Arrhenius has told that conductivity of the electrolyte is depending on how much concentrated the ions are. How much concentrated the ions are in the solution, that will determine the conductivity of the solution. Okay. Next he said that the number of positive ions will be equal to number of negative ions. Therefore, an electrolytic equilibrium will be maintained. Okay. Next he said, in non-electrolyte only molecules are there, no dissociation is there, no electricity is conducted. Clear? Next he said that the extent to which an electrolyte will break up into ion or dissociate, same thing, is depending on the degree of dissociation. degree of dissociation, as I've already told you to be before also, right? Number of molecules removed by total equal to 100 is degree of dissociation, alpha. Okay, this was the theory that was proposed by Arrhenius theory. Now there are some contradictions to the modern theory. What is that contradiction? Contradiction is there with water. Contradiction is with water. Arrhenius said that water ionizes NaCl. Suppose let's say NaCl. Example NaCl. Okay. Arrhenius said that water will ionize NaCl, then it will conduct electricity. But modern theory says NaCl is already ionic. Water will just render the ions mobile by breaking the bond. Clear? This is the contradiction between modern and Arrhenius. Arrhenius said water will ionize the compound, but modern theory says they are already ionic. Water will only render them mobile. How? By breaking the bond or force of attraction between the electrons. Okay, clear? Clear? By breaking the electrostatic forces, it will just make the ions mobile, not electron, ions. Clear? Ions, because ionic compounds are ions. Clear? Okay. Next comes Faraday's law of electrolysis, a very important thing. Faraday's law of electrolysis. See, Faraday's law of electrolysis is basically saying that the mass of the electrolyte that will be formed at an electrode is proportional to how much current is flowing. Simple. How much mass of electrolyte will be formed at an electrode is directly proportional to the amount of current that is flowing through the electrolyte. This was said by Faraday. Faraday's law of electrolysis. Clear? Okay? Acha. Next is that this process of electrolysis that we are doing. Everywhere you see electrolysis process, let me show you. Acha. Pb2 plus 2 electron forms Pb, and on the other hand Br minus, actually 2 Br minus 2 electron, let's write Br minus only, forms Br. Nascent Br will combine to give you 2 Br. This is Br2. Now see, this is oxidation happening, so this is reduction. Okay, this is oxidation happening, this is reduction. This is oxidation happening, so this is reduction. Oxidation reaction is called redox reaction. So what is the ultimatum? Ultimatum is that electrolysis is always a redox reaction. This is the proof. Clear? Here is positive, that is reduction, here is oxidation. Clear? So electrolysis is always a redox reaction. Next, direct current. If you apply alternating current, cannot. Why? Terminal keeps changing. So there is ununiform electrolysis. Ununiform electrolysis. Suddenly this will turn positive, this will turn negative. Again the next step will turn. This is alternating current. Clear? So alternative current will produce no chemical change. Desired effect will not be seen. Clear? Okay. Next we are coming to electrolytic dissociation. Electrolytic dissociation is basically the process of breaking up of an ionic compound into ions. It is electrolytic dissociation. In its aqueous solution definition, we are saying electrolytic. Clear? So if Na and Cl, let's say PbR2, and this is PbR2, right? So PbR2 breaks up into Pb2 plus ions and Br minus ions. When it is done, electrolysis is done. We have it. Electrolysis of PbR2 later on in the chapter. Okay. Okay. Next is dissociation, though we know. Breaking up. What is ionization? Ionization is generally applicable for acids. Okay. Polar covalent compounds converted into ions. Polar covalent compounds are converted into ions upon dissolving in water is called ionization. Acha. Suppose I write HCl plus H2. Acha, tell me, in HCl is there any ion? H plus and Cl minus is present? No. But when we add it in water, what happens? H plus plus Cl minus happens. No, this is H2O plus. We are writing H plus. So this, where does this come from? Here? No. It comes from dissociation. Dissociation? No. Ionization. That is converting. Initially there are no ions present, but now there are ions present. But here you see, initially there are ions present, right? It's actually the compound is Pb2 plus Br2 minus. This is the compound, right? This is the compound. Initially this is the compound. Clear? So there are already ions present in the compound. There are ions present in the compound. Clear? But here ions are not initially present, they are being formed. Difference point number 1. Clear? Difference point number 1. Next, polar covalent compound. Polar covalent compound will show dissociation, and this is electrovalent compound PBr2. So electrovalent compound will show dissociation. Clear? Understood? So let me repeat once more. Ionization is polar covalent compound getting converted into ion upon dissolving in water. Ions are not initially present. They are formed after converting. On the other hand, in case of ionic compounds, they are already present. They are just broken down and they are just made free. They are bounded, that is broken down, and they are made free. Okay? So that is all from the first part of electrolysis. In the next part of electrolysis, we will be learning about electrochemical series and then moving on to electrolysis of the few salts that are given in your book. Okay? So see you all in the next video. Keep watching. Thank you.